What is OOP's law? OOP's law refers to the fundamental principles of object-oriented programming, OOP, that govern how objects interact in a system. These principles include encapsulation, abstraction, inheritance, and polymorphism. What problems does OOP solve? 1. Code reusability. Avoids writing the same code multiple times by using inheritance. 2. Data security. Protects sensitive data using encapsulation, preventing unauthorized access. 3. Scalability and maintainability. Makes it easier to modify and extend applications without breaking existing functionality. 4. Code organization. Structures complex applications into smaller, reusable objects, improving readability. 5. Flexibility. Polymorphism allows a single function to work in multiple ways, reducing code duplication. 1. Encapsulation. Hiding data and protecting it. What is it? Encapsulation means hiding the internal details of an object and only allowing controlled access through specific methods. It ensures that sensitive data is not directly modified and can only be accessed in a controlled way. Real-world example. Bank account. Imagine you have a bank account where your balance is stored in the system. You cannot directly change the balance, like editing numbers on the screen. Instead, you have to deposit or withdraw money through the bank's official process. The system automatically updates the balance based on valid transactions. Encapsulation in OOP ensures that data is accessed and modified only in a controlled way, just like a bank account. 2. Abstraction. Hiding complexity, showing only essential details. What is it? Abstraction means hiding the complex internal workings of a system and only exposing the necessary functionalities to the user. Real-world example. Driving a car. When you drive a car, you just use the steering wheel, accelerator, and brakes. You don't need to know how the engine, fuel combustion, or electronic circuits work internally. The car hides complex mechanisms and only provides a simple interface for driving. In OOP, abstraction allows developers to use complex systems, like a database or an API, without worrying about the internal implementation. 3. Inheritance. Reusing code and avoiding duplication. What is it? Inheritance allows a child class to reuse properties and behaviors from a parent class. It promotes code reusability and avoids duplication. Real-world example. Family, parents, and children. A child inherits certain characteristics, like eye color, hair type, or height, from their parents. The child doesn't need to relearn everything. They get it by default. However, the child can also develop their own unique traits, e.g., hobbies, skills. In OOP, a parent class provides common features, and child classes inherit those features while adding their own specialized behavior. Small blue diamond. 4. Polymorphism. One name, different behavior. What is it? Polymorphism means the same action or method behaves differently based on the situation or object using it. It allows flexibility in coding. Real-world example. A person communicating. You talk differently depending on the situation. With friends, you speak casually. With elders, you speak respectfully. In a meeting, you use formal language. Even though the action is the same, talking, the way you do it changes based on the context. In OOP, polymorphism allows different objects to use the same function in their own way, making the system more flexible and scalable. Summary of OOP concepts with real-world examples. OOP concept meaning real-world example. Encapsulation hiding data and allowing controlled access bank account. You can deposit/withdraw, but not directly change the balance. Abstraction hiding complexity and showing only necessary details driving a car. You use the steering and pedals, but don't worry about the engine. Inheritance reusing code by passing features from parent to child family. Children inherit traits from parents, but can have their own characteristics. Polymorphism, the same function behaves differently in different situations talking. You speak differently with friends, elders, and in meetings. Why is OOP important in real-life software development? Encapsulation ensures data security, e.g., preventing direct modification of bank balances. Abstraction reduces complexity, making software easier to use, e.g., APIs hide database details. Inheritance reuses code, making development faster and cleaner. Polymorphism makes systems flexible, allowing new features without breaking old code. Would you like an example related to ASP.NET Core and how these concepts are applied in real projects? Smiling face with smiling eyes.